Welcome to this lesson on slope-intercept form. Today we're going to talk about how to use the slope and y-intercept to draw graphs and write equations, and how to use or how to find the y-intercept and slope from equations and really just be able to work with that slope-intercept form and those different pieces. So first is we need to define both y-intercept and slope-intercept form. So the y-intercept is where the line crosses the y-axis, and instead of saying the line, we'll say the graph. It's kind of large. Crosses the y-axis. So, for example, if we have a coordinate plane, and we're at 1, 2, put this at 3, the y-axis is here, that's where it crosses, so the y-intercept is 0, 3. In slope-intercept form is y equals mx plus b. This will be your example. So it's an equation we can use to graph lines, or a linear equation that we can use to graph lines. Really for this one, I just want you to have this equation written down. All right, so just as a review, the definition of slope. So slope is the comparison of the change in the height divided by the change in the length. And instead of saying divided by, because it's a comparison, it's a comparison of the change in height to the change in the length. Okay, so if we look at our mountain here, we have the rise and the run, and that gives us our slope, so going from one to the other. So we know our slope, so m is equal to the rise over the run, or we can use coordinates, and we know that our slope is equal to the change in y over the change in x. All right, so slope-intercept form, we said, takes this form of this equation. Previously, when we talked about slope, we said that m, when we talk about algebra in particular, m is always what we use as our variable for slope. So in the form y equals mx plus b, we found that the slope is our m. Okay, and then here, plus b, b is actually your y-intercept. So it's not that this is 0, 3, it's that y coordinate. And we'll get into that a little bit more in a little bit. So here we're going to identify the slope for each of the equations. So I know the form is y equals m times x plus b. So in this case, we're looking for the m. Right, so, and the m is going to be multiplied by the x. So here we have 3. So our slope is equal to 3. Here we have 7/6 times x. So our slope is a rise of 7 and a run of 6. And then here we have -4/5. Okay. Again, super simple. You just have to make sure that, one, it's in this form of y equals mx plus b. If it's not, we have to rearrange it to be in that form, but that is for a later date. Okay, so now we're going to take those same equations and we're actually going to find the y-intercept. Now this is a little bit different. So that y-intercept, again, we have y equals mx plus, now we're looking for that b. So here I have 5 as my y-intercept. However, it's -5. When you see that it's -5, you have to look at this equation as an addition equation. So it's like y equals 3x plus a -5. But instead of writing plus a negative, we usually just say -5. So anytime you see minus, that implies to you that your y-intercept is actually a negative. And remember, your y-intercept needs to be 2 points, so the y-intercept is 0, -5. Okay, here, your y-intercept. Again, we've talked about how your x is always 0, and even though it's a fraction, your y-intercept is 3/4, and we know it's positive because it's plus. And then here, we have nothing. There is no b. Well, this would be the same thing as saying y equals negative 4/5 x plus 0. But we don't write plus 0 because we know plus 0 means that it's itself. It's exactly the same. Okay, the identity property tells us that anything plus 0 is itself. So here, my y-intercept is going to be, my x is always 0, and since this is plus 0, we just don't write it, I know that my y is 0. So my y-intercept in this case is actually at the origin. Okay, and a common mistake is to think that it's always the origin. It's not always the origin. Graphs do not always start there. Okay, so now we're going to write an equation. So now we have our m and we have our b, and we know that this is our y-intercept. So even if they said, here's your y-intercept and here's your slope, you should be able to put these things together. We know that it's always going to be y equals. Remind ourselves it's y equals m times x plus b. In this case, my m is 2/3, so y is equal to 2/3 times x. It's a negative 5, so I'm actually going to subtract 5. If you're more comfortable and want to start off by saying y is equal to 2/3 x plus a negative 5, and then change it back, that's fine, but we need to be at this point. So if you want to go from here to here, that's fine. If you can jump right away to negative 5 means minus 5, great. Here we have a negative 1/2. That doesn't change anything. That just tells us that what we're multiplying by is negative. And b is 0, so we can actually just leave it like this. We don't have to put plus 0 because plus 0 gives us the exact same answer. Here my slope is 0, so since my slope is 0, I know that y is going to be equal to, so 0, let's take a look at this, minus 2. Well, 0 times x is going to give me 0. So this is actually telling me that y is equal to negative 2. So all of my y values are negative 2. So if you look at what this does to the graph, so here's negative 2. So when x is 0, y is negative 2. When x is 1, y is negative 2. Negative 2, negative 2, negative 2, negative 2, negative 2. So you know that this is going to give you, so whenever y is equal to just a number, because the slope is 0, remember, when we have a slope of 0, that means that it is a horizontal line. So when our line is horizontal, the slope is 0. So right off the bat, you know that it's just going to be y is equal to whatever the y-intercept is, and that your line is going to be a horizontal line. All right, now we're going to actually graph the equation. So I know we've talked about how you can plot your numbers and you can say, okay, x is 0 and plug in 0, and I do 3 times 0 is 0, 0 minus 1 is 1, and then in my table I get, so when x is 0, y is negative 1. Well, we can actually do this a lot faster without having to find the values. So I know that this is my y-intercept and this is my slope. So my y-intercept, I know x is always 0 and y in this case is negative 1 because it's minus 1. So I can actually start my graph and know that I start at 0, negative 1. Now my slope is 3. Since my slope is 3, I know that that means I have a rise of 3 and a run of 1. So I go up 3, so 1, 2, 3, and over 1. Okay, and I can actually jot that out here. So I go up 3, over 1, up 3, 1, 2, 3, over 1. And that's my next point. This also means, though, that I can go down 3 and left 1 because negative and negative gives me positive. So I can go 1, 2, 3, and left, 1, 2, 3, and left. Okay, and then I use a straight edge to graph my point. And actually, this is a lot harder to do, so I'm just going to get myself an arrow to use. There we go. There we go. All right. So again, first you graph the y-intercept. And then second, you use the slope to plot at least 2 other points. Now, don't forget to double check. This is a positive slope, so when the slope is positive, so that means from left to right, it should be going, and I'll actually make this an L. From left to right, it should be going up. And since it's going up, I know that at least that part of my graph is correct. Okay, so now we have a word problem. So the base pay of a car salesperson is $210 per week. She can earn 20% commission on any sales. So that equation, and I promise you this was actually given to me. I didn't find this because of your last unit. Our equation is she starts with, because we know she has to get her salary, and then we add 20% of whatever her sale is. So if her sale is $100, we multiply that by 20% and then add it to 210, which gives us her total earnings. Okay, so here I know my equation is y is equal to, well, let's rearrange this. Let's put it in the form of y equals mx plus b. Since it's addition, I can just move these around and say that y is equal to 2/10 s plus 210. Instead of 2/10 as a decimal, let's write it as a fraction, so it's actually slope. And then reduce it, so 2 and 10 can both be divided by 2 and give us 1/5 s plus 210. So my equation is y is equal to 1/5, and then we can say x because down here this is our x value, which is our sales, that can replace the s, plus 210. Okay, so my y-intercept, my graph will cross at 210. So now here it's hard to, so if I have a sale of $100, I can plug in and I can say, okay, well, y is equal to 1/5 times 100 plus 210. Well, 1/5 of 200 is 20 plus 210, so that is 230. Okay, so I can go by hundreds down here because that'll be easiest to multiply by. And then here I have this zigzag line in here because it's going to be harder for me to put all these numbers in for, I don't want to put everything from 0 to 200 because that's going to be a lot. Even if you count by 5s, 10s, 20s, you know, it's going to be a lot. So sometimes what we do is when it's going to be a bigger number, we put the zigzag line in because you know your graph is going to cross at 0, 210 because your y-intercept is 210. So when x is 0, y is 210. So this should actually be 210. So that should be the smallest amount of money that she makes. So this actually isn't going to start in the origin because even if she makes 0 sales, she still gets $210. Okay, but then if she has $100 worth of sales, she earns, and I'm actually going to drop this down a little bit so it matches the lines, but if she has $100 worth of sales, she earns $230. And then if she has, so skip a line, there we go, $200 worth of sales, it'd be $250. Okay, so this is where rise over run is really a little bit more difficult because of the fact that you're working with such large numbers. So sometimes it is a better method to go through and find your answers instead of trying to plot it using this. Otherwise, what you could do is you could go through and say, okay, well, 200, and then zigzag it and do 100, and know that for every 100 you go over, for every 100 you go up, you have to go over 500. Okay, but we can dig more into that when we're practicing our problems. But I wanted to give you an example of bigger numbers because sometimes it is just worth it just to plug in the numbers and figure it out. When we're working with smaller numbers like these, though, it's definitely easier to say, all right, here's my y-intercept, up, over, and go from there. All right, and then the last part of this, we're going to write an equation without taking a lot of effort, I guess, so to speak. And we're going to look and say, okay, well, my y-intercept is when x is 0, y is 1, so it's 0, 1. And my slope, so I'm going down 1 to the right 3. So my slope is -1/3. So this is my m, this is my b. So y is equal to m, which is -1/3, which when I go from left to right, it's going down, so it's negative. So I know this is right. My y-intercept is positive, so it crosses the y-axis on the positive part of the y, so it's going to stay plus. And I just put that y number in there, so it's -1/3 times x plus 1. So actually, none of these in here are correct. So you can just take those off. Not really sure why those stayed there from a previous slide, so I apologize. All right. Then you have these U-try problems that I'd like you to do on your own. You're just finding the slope, finding the y-intercept. Then here I gave you 2 points, so you have to use the 2 points to find the slope. And then notice what this is. Okay, because you need the slope and the y-intercept to write your equation, and then you need to graph an equation, and then you need to use this graph, and I'll make these dots a little bigger for you, and you can put them onto your notes to find your slope and your y-intercept and write your equation. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.